Albert Einstein predicted that we would never be able to see to the edge of the universe. The James Webb Telescope has now observed a void in the extremely early universe that could confirm this prediction. But what are we really seeing here? Is it really a void, and could it be the beginning of the universe? Scientists may have discovered a shocking fact: a strange void at the beginning of time may now confirm a remarkable prediction by Albert Einstein. Imagine how, 100 years ago, scientists slowly began to look beyond the edges of the Milky Way. What they saw astonished them. At first, it was just hazy nebulae, then it became clear that these nebulae were other galaxies. First, the small and large Magellanic Clouds became visible, then the Andromeda Galaxy, and finally, the shocked scientists realized how many more galaxies there were. Based on these findings, ideas such as the evolution of galaxies and the infinity of the universe were born. Then, Edwin Hubble observed that distant galaxies were moving away from us, and the idea of expansion was born. Shortly afterward, the Belgian scientist Georges Lemaitre proposed the Big Bang theory. This all took place slightly after the time when Albert Einstein presented his theories of relativity. Many of the purely theoretical predictions made in the 1910s and 1920s were confirmed by the new discoveries. However, Einstein was unsure throughout his life whether the universe really had a beginning and an end. Although he fundamentally accepted the Big Bang theory, he was always certain about another interesting question. Even if the universe did have a beginning and an end, he was certain that we would never be able to see this beginning and end, no matter how good our telescopes were. How did Einstein come up with this idea, and what does it have to do with the void discovered by the James Webb Telescope? Albert Einstein's devastating prediction is one of his most profound considerations. He was certainly one of the most important physicists of the 20th century, and many of his predictions are still cornerstones of modern science today. One of his major predictions was that we could never directly observe the absolute beginning of the universe. Einstein gave two interesting reasons for this. Firstly, the theory of the Big Bang and other theories based on it postulated that there was no light for hundreds of thousands of years immediately after the Big Bang. Today, scientists call this era the Dark Ages. So, how could we see a point in time or an event with telescopes when there was no light? There are even some exciting answers to this question today, such as using radio telescopes. These do not see but hear. However, researchers are pretty sure that the Big Bang was not a loud explosion but took place in complete silence. The space in which an audible explosion could have occurred did not even exist at the time of the Big Bang. Space itself only came into being with the Big Bang and was formed as a consequence of this event. Radio telescopes detect waves that are usually far from the audible sound spectrum. Space hardly conducts any sound, and only a few other waves penetrate the interstellar medium, which can be made audible using modern technologies. Therefore, we would not be able to hear the presumably silent beginning of the universe. We discovered the cosmic background radiation back in the 1960s and have since mapped it very well. This radiation is considered to be an aftereffect of the Big Bang, and much evidence for the Big Bang has been derived from it. However, the microwave background has never led us directly to the Big Bang. So, here too, we apparently have no way of detecting or proving the absolute beginning or Big Bang. However, Einstein was also of the opinion that we could never see all the way to the beginning or edge of the universe for another reason. He believed that, due to the expansion and extension of the universe, the beginning would move further and further away from us and would therefore be out of our range of vision, so to speak. Albert Einstein also believed at times in a curvature of all space. This means that the starting point could also be behind a kind of horizon that would forever obscure our view. Now, imagine again, that this was at a time when the best telescopes were only capable of blurring neighboring galaxies. Today, we know of the existence of millions of galaxies in a universe teeming with galaxies expanding so much and getting bigger and bigger, it could be really hard to see far at all. But that's not true. Although our cosmos is so rich, the spaces between the galaxies and galaxy clusters are so large that we can now see 13.6 billion years away with our telescopes. That would be very close to the Big Bang, and with the James Webb Space Telescope, we are already pretty close. But the Webb telescope does not show us what scientists called the Big Bang 100 years ago. The JWST discovered a strange void. I'm sure you've heard that the JWST has discovered an extremely large number of very old galaxies that now even call the Big Bang into question. But did you also know that the JWST has discovered a strange void that could confirm Albert Einstein's prediction of the non-observability of the absolute beginning? Absolute voids are mysterious spaces in the universe that are so empty that they actually contradict the theory of relativity. But how can it be that they confirm Einstein's ideas about the invisibility of the beginning? This is initially explained by the fact that the emptiness was thought to be an indication of the Dark Ages, in which there was not much, at least no stars and no galaxies. Some researchers believe that the discovery had at least confirmed the existence of this APO. But then came the shock. The darkness turned out to be an extremely distant void. We also know of closer and more recent voids. These voids already pose puzzles, but in the extremely early universe, voids are once again scientific impossibilities. They do not fit into the idea of the homogeneity of the universe, which is directly linked to the idea of the Big Bang or expansion. Voids are too big and too strange. They have an inhomogeneous character and contradict some of the foundations of our cosmology. A void does not really confirm Albert Einstein's prediction, however, the Webb telescope seems to confirm the view of the brilliant scientist in another way. The telescope has so far found no trace of a beginning or an early stage of the universe. The images of the allegedly extremely early universe only show structures and galaxies that do not appear much different from those we know from the universe we can observe more closely. Could a void have been the beginning of the universe? The question now arises as to whether a mysterious void could have been the origin of the universe. We cannot completely rule this out because ultimately, we never know what voids really are. These days, we also have to admit that we do not know how the universe really began. Voids are probably empty, but we don't know that for sure either. It's possible that they contain some kind of matter that we don't know about yet. Imagine dark galaxies. Voids are sometimes interpreted as some sort of parallel worlds, and some scientists see them as scar tissue from the collision of universes in the multiverse. Other crazy theories claim that aliens darken the galaxies and avoid to harvest energy. So, you can already see that these mysterious voids challenge our scientists and lead to the craziest theories. Of course, it could be that our universe was created in a large void. The mere fact that we cannot prove the opposite reinforces such an idea. That leaves the question of how matter was created. What are singularities, really? We have already talked about the nothingness from which the universe is said to have emerged. If that was the absolute starting point, how could we observe it? After all, it was nothing and therefore not detectable for us. A singularity is a point at which all forces are either so condensed that our dimensions of values and sizes fail, or everything that exists is concentrated into this one point. The point consisted of a fluctuation of possibilities that existed in a state of complete equilibrium. A previously unknown event is said to have disturbed this standstill at one point, and creation began from this tiny point. Everything that we know and can see today came into being from that. This means no less than that the information for you and me, all life on this Earth, every star, and every exoplanet was contained in this tiny dot of nothing. The question of how an infinitesimally small dot of nothing can contain everything is one of the great mysteries of science, and it's currently unclear whether we will ever be able to solve this puzzle. We find these mysterious singularities in another place in the universe, namely in the center of black holes. These, in turn, are found at the center of pretty much every known galaxy. Black holes are what remains when stars of a certain size explode, at least that's what scientists assume. No one has ever been to the center of a black hole, and as we have now discussed, we have hardly any way of seeing the absolute starting point of the universe if it existed at all. Everything is based on calculations that made sense until the James Webb telescope discovered something different from what our theories postulated. The Webb telescope shows that the universe must be much older than we assumed, or that its nature is quite different from what all our calculations predicted. Black holes are also one of the great mysteries of cosmology. They are huge, enormously heavy, and all the forces inside them very probably increase to infinity, so that we have no way of ever really exploring this infinite point, which is one with a singularity, using conventional methods. All hopes are currently pinned on new supercomputers, which, with the help of their own intelligence, can decode the secrets of the universe and show us the true connections. To this end, scientists are now borrowing the intelligence of quantum computers, which are supposed to be the universal information stores of the visible universe.